This next lab is built like a couple of puzzles. The network begins with everything working, including OSPF. Your job is to look at the metrics for the routes that the lab wants you to have and figure out which interfaces need to have their OSPF costs changed and to what values. Let's get into it. Let me set the context a bit. With the official Cert Guide, Volume 1, Part 6, Chapter 23, you'd read the background used in this lab that you'd be practicing here. So what's it about? It's about changing the OSPF metrics of routes. Here's the direct link to the lab. It ends in CLab 314. For all of these config labs, the blog page starts with the what to do, the scenario and tasks. Then a short mention to say, hey, time to do the lab, do it in Cisco Packet Tracer or CML, and then the page ends with the answer and explanation. You can do the lab totally from the blog page, but for extra help and to dig deeper into what the lab's about, I've got this intro video that you're watching now, and there's also a lab review video that'll get you deeper into the answers. The topology is pretty straightforward. We've got 4 routers. We've got a WAN link from R1 to each of the 3 routers on the right. So think of those routers more as branch office routers. But notice R2 and R3 are connected to the same LAN subnet on the right. Okay? Now, what about that initial configuration? Well, there's a lot to it in terms of volume, but it's nothing all that tricky necessarily. It's kind of the same cookie cutter kind of configuration all across the board. So generally what's in there, you've got interfaces that are going to be in a working state, an up state at the beginning of lab. The IP addresses are already configured, so you can look at those on the blog page. I'm going to show them here as well. All interfaces are placed in OSPF area 0. OSPF is enabled on all those interfaces. We've given all the routers obvious router IDs to make interpreting show command easier or show commands easier. They're all 111122223333 and 4444 respectively. Everything should be up and working. Never hurts to verify that when you open up your lab to begin, but that's your beginning state. In fact, if you wanted to do some pings, ping from anywhere to anywhere should work when the lab starts. This lab isn't about making it work. It's about changing the metrics that OSPF chose by default. All right. So what is that initial working configuration? Well, here's the relevant config on router R1. So let me work through it systematically. R1 in the diagram shows 4 interfaces for this lab. So we've got 4 interfaces in the config. Then under each, we've got a pair of similar commands. For each interface, we've got an IP address command and an IP OSPF1 command. The IP address commands configure the IP address on the interface. The IP OSPF1 command enables OSPF tied to OSPF process 1, which is shown at the bottom of the page. All right. So all 4 interfaces enabled for OSPF tied to this OSPF process. And by the way, all those IP OSPF1 commands end in area 0, placing those interfaces in area 0. Last thing, notice after router OSPF1, you'd be in router configuration mode for OSPF. The router-id command lets you explicitly configure the router ID to use. In this case, it'd be 1111 on router R1. That, of course, will be different on each of the 4 routers. So this config's a little longer than the other 3 because the other 3 have only 2 interfaces. So here, router R2 has 2 interfaces. So it's got those 2 interfaces shown in the config. They both have IP address commands and both have the same IP OSPF1 area 0 command, enabling OSPF and tying it to OSPF process 1. But router R2's router ID is 2222 instead of 1111. Now R3 and R4 have a very similar pattern. 2 interfaces, IP address commands on each, IP OSPF1 commands on each, placing the interfaces in area 0 with router ID 3333. And you guessed it, same pattern on R4, but now with router ID 4444. So the network works. All the routes are learned. So what are we doing here, right? Well, we're influencing the OSPF metrics that are chosen. So the first thing is you want to reconfigure all 4 routers to use the same reference bandwidth. The lab asks you to set it to 100,000. The default is 100. Real networks, you do this all the time. You want the reference bandwidth to be at least as big a number as your fastest link in the network. All right, that helps out with how OSPF does its default cost calculations. All right, so we'll do that. And then after that, the lab has some extra rules that aren't really relevant to real life, but just there to drive us toward a single answer so we can talk about it in lab. So first off, for configuring OSPF costs, you're allowed to configure costs on router R1, but you're not allowed to configure them on routers 2, 3, and 4. Solve the config for costs on R1. You can configure the cost directly, but you cannot change interface bandwidth, which is used in the calculation of cost. All right, so it's got to be direct configuration. Those are the rules. Then the route to the R2, R3 subnet. R1 could calculate a route through R2 and another one through R3. And in fact, with default costs, it's going to be a tie. And R1 is going to have routes via both paths in the routing table. But when the dust settles, you should make sure that R1 uses only this route through router R2. Now that's all part of the requirements, but the tricky part, the part that's the puzzle, if you will, is the idea of these 3 routes that are the puzzles that you have to work through. So the first one is a route from router R1 to subnet 2, if you will, this subnet on the far upper right. So at the end of the day, we want the metric for this route to be 150. That is, if I do a show IP route in router R1 and I see its route to subnet 2, I want to see a metric of 150. That's your marching order. And similarly, R1's route to that R4 LAN subnet, subnet 4, we want its metric to be 220. And then from R4's perspective, its route over here to subnet 1, it needs to be 180. So it's the metric of the route, not the interface cost. I get that question from time to time with this lab. It's the metric of the route as seen in show IP route. That's your job. There are some assumptions, of course. The initial config is there. Those interfaces are up and up. It's all pre-configured. OSPF is up and working. But if I were doing the lab, I would bring up the lab and maybe do a few show commands and make sure everything's working before I start thinking about doing the lab exercise. So if you're using Cisco Packet Tracer, go for it. Go ahead and do the lab now. However, if you're using CML, I've got a few more comments for you so you can have a good lab experience. As always, I do the labs on the blog page using interface IDs that make sense for the Cisco Packet Tracer file. So in the blog page, we've got outer interfaces, the LAN interfaces that are gigabit 00 and 01. Well, the CML files that are supported by CML-Free edition don't have any gigabit type interfaces. So first off, we have to change the interface IDs for the CML file that I've supplied to you. So in this case, the conversion is easy. The numbers can stay the same on those 4 interfaces, but the type changes from gigabit to Ethernet. So just watching on the right in the diagram, those G00s become E00, and the G01 becomes E01. Now, if that's what it was like across the diagram, that would be great. But those inner interfaces have 3-digit interface IDs, and there aren't any in the CML-Free router operating system. So in that case, what I did was key on the center digit of the 3, and I use those in the new 2-digit IDs. Let me show you what I mean by that. All the G0 something 0 interface IDs in the middle become Ethernet 1 / and that same second number. So the second numbers stay the same, if you will. So looking on the right, notice we got the pattern in the middle of 012, 012. All right, I'm backing up again. What the lab says on the right here of the WAN links, gig 000, 000, 000, 000. See that 0 in the middle? Now they're E1/0. So those are the new interface IDs. The blog page has the packet tracer appropriate interface IDs. When you import into CML, you'll see these other interface IDs. All right. So that's one thing you have to be aware of. The other is I've added some extra config on all the interfaces on all 4 routers, specifically the bandwidth 1,000,000 command. So bandwidth is an interface setting that by default tends to match the physical speed of the interface. So the lab was written assuming 1 gigabit interfaces. So the bandwidth ended up being defaulted to 1,000,000 kilobits per second, which is equal to 1 gigabit per second. All right. 1 million kilobits is 1 billion bits or 1 gigabit. So in CML, we have these interfaces that are Ethernet interface type, and their bandwidth defaults to a much smaller number, the equivalent of 10 megabits per second, which is 10,000 kilobits. So here's what I've done in the config. I've changed the bandwidth to match what gigabit interfaces would show by default, because this bandwidth setting impacts the instructions in the lab. So basically, I've revamped the bandwidth so it matches what you would have seen in Packet Tracer or Real Gear that have gigabit interfaces. Hope you enjoyed the video, but most of all, hope you go do the lab now. You should also see an image show up where you can click and get ready to see the config lab review video as well, but do the lab first. Hey, thanks for hanging out. Talk to you soon.